everyone, welcome again to our physics session of practicals, Mama Physics channel. Welcome. Today we will discuss about electricity theory of practicals. Measurement of electricity, it is categorized into the following practicals. We have verification of Ohm's law, EMF and internal resistance of a cell, determination of unknown resistance, determination of resistivity of material, determination of internal resistance of a voltmeter, comparison of EMF of the cell, comparison of two resistances, calibration of an ammeter, calibration of voltmeter. Various methods can be used in our physics practicals of electricity. We have voltmeter to ammeter method, whereby major apparatus will be voltmeter and ammeter. Also, we have wheatstone bridge. We have meter bridge, we have potentiometer. In our practicals, we're going to use various equations. We have V equals to IR. This is Ohm's law. Also, we have our general equation of electricity, which is E equals to I R plus R. Now, this is EMF, current, external resistance, internal resistance. Also, we have R equals to resistivity, L over A. This equation here is from the factors that affect electricity that include resistivity, length of the conductor, area of the conductor. Also, temperature can affect resistance. In doing our practicals, we have different natures of graph. Generally, electricity graphs are based on the linear equations. That is, the form of linear equation is like y equals to mx plus c. This y here is the parameter in the vertical axis. This m is the slope. This x, the parameter in the horizontal axis. And this c is the intercept of the y-axis. Various graphs include this graph has a negative y-intercept. That is, for this equation, the equation of this graph is y equals to mx minus c. Our intercept is the negative value. Also, we have this nature of graph. This one here has the positive intercept of the y-axis. That is positive c. Here it's negative c. Also, this graph here has its origin, the graph is passing through the origin. The nature of it will be y equals to mx. It does not have any y-intercept. Also, we have the graphs that have the negative slope. That is, the equation can be like the negative slope. We have various ways of deducing an equation. Various equations depend on the type of the circuit that is being shown. For example, this circuit is circuit number 1. Our origin is from the general electricity equation, that is E equals to I R plus internal resistance. Whereby, if you're told to draw the graph of R against 1 over I, then make R the subject. E and I. So, R, 1 over I, minus R. From this equation here, if you're told to draw the graph of R against 1 over I, that means this will be the vertical axis, this one here will be the horizontal axis, Well, this one here will be our slope. This one here will be our vertical axis intercept. From, if I arrange it like this, then I compare it with this, then R corresponds with Y, E corresponds with M, 1 over I corresponds with X, while negative R corresponds with negative C. Generally, E over cell is 1.5 V, and R over cell is approximately 0.8. So, measure the graph. Also, second circuit structure. Okay, this is a voltmeter, switch, cell, ammeter, rheostat, variable resistor. Okay, here if you're told to draw the graph of V against I. From our general equation of electricity, that is E equals to I R plus R. Then E equals to IR plus IR. This IR from Ohm's law equals to V. V equals to IR. Therefore, we put V instead of IR. Then we arrange it according to the linear equation. It's V against I, so V should be the circuit. To be E minus IR. V against I. Arranging it in this form will be V equals to negative I R plus E. Negative R M X, then plus E. Therefore, here our slope will be negative R. The V-intercept will be E. As we said, probably and mostly E over cell is approximately 1.5. Therefore, you have to make sure you're drawing a graph to make sure your E, your V-intercept is 1.5. Here, our V-intercept is positive. The measured graph will be like this. It's a graph that represents a negative slope because our slope here has a negative. Also, our V-intercept, which is E, here it's positive. This here is the circuit structure. In the question, you'll be told to vary this resistance by putting the resistance, the standard resistor of 4, then 6, after 6, then 8, then 10, then 12, following a certain range. After that, a graph of 1 over I against R. Electricity equation: E equals to I R plus E over R plus R equals to I. Then we reciprocate this to be R plus R over E equals to 1 over I. 1 over I is R. R over E plus R over E equals to 1. 1 over I will be the circuit and equals to 1 over E R plus R. 1 over I in the vertical axis, 1 over E is our slope, R in the horizontal axis, and R over E, it's the 1 over E intercept from Y equals to M X plus C. This 1 over I corresponds to this Y, 1 over E corresponds to this M, R to this X, R over E to this C. So from this equation you can see that we're having a positive slope and a positive 1 over I intercept. It's as follows, the graph. Also, we have another circuit structure. So our circuit has two switches, one cell, one voltmeter, and a standard resistor. The graph of 1 over V, Vs1, this circuit structure. Okay. Now, here we have our voltmeter, our switch, our cell, and here wire that has certain length. A wire that has a specific length has resistance from R equals to, that is, a wire that has length has its resistance, because every wire has its resistivity that is constant and a constant diameter from which you can get area. So if you have length, then practically we'll have the resistance. Now in the question, you'll be given a wire of which you have to vary the length by starting with maybe 20, then 30, then 40, then 50, then 60. Half of 1 over V against over L from E equals to I plus E equals to I R plus I R. Then, as I said from Ohm's law, IR equals to V. So it's E equals to I R plus V. Then, okay, here I divide with V in both sides. Then I get E over V equals to it's supposed to be V IR over V plus 1. Then from here, I factor out E outside, E, then 1, equals to 1 over R and V plus 1. I divide by E both sides. Divide by E. Divide by E to come here, and here, E. Therefore, I have 1 over V equals to 1 over E plus IR over E V. But from Ohm's law, V equals to IR. So here, instead of writing V, I'm writing IR. 1 over V equals to 1 over E plus 1 over R E IR. V equals to 1 over E plus R over R E. But our aim is to draw the graph of 1 over V against 1 over L. But here, as you look at our equation, it does not have any L, but we have R. As we know, R equals to resistivity times L over A. So we substitute this one here. Instead of R, we write resistivity times L over A. 1 over V equals to 1 over V. Over then 1 over V equals to 1 over E plus this A will come here